So what we're going to discuss now is commands and queries. And where once there was a single object for querying our data, whether we're writing to or reading from, now we have two. We have a command and we have a query. And the difference between them is that a command always does something. It modifies the state in our database. And it should not return a value. And all of our create, updates, and deletes are going to be commands because they modify the state of our application in some way. Now, a query will answer a question. It does not modify states, and it should return a value. And we'll be using queries for things like getting a list of our activities, or getting the details of a single activity. So that's great. So we separate our commands from our queries, but what does this really give us? Well, let's take a look at CQRS, and command query separation and CQRS are kind of talked about in similar terms, but CQRS is more concerned about the flow of our data. And as a request comes in, it's either a command or a query, then our commands are going to use our domain and our persistence layer to update our database, whereas in the case of a query, we're really only concerned with retrieving data from the database. Now, this is the simplest method of implementing CQRS with a single database, and it's hard to define any significant performance benefits from doing it this way because both our write queries and our read queries are both going to the same database. And in terms of CQRS, in the case of a single database, our commands use a domain, our queries use a database, and it is simple to implement. So let's look at another scenario, a slightly more complex implementation of CQRS, which uses a read database for queries and a write database for commands. So in the case of commands, we could have a database that's optimized for writes, and we could have a read database that's optimized for queries. And if you base it on the fact that in most applications we're going to be reading our data a lot more than we're going to be writing from our database, then a specific database for reading can make our application significantly faster. And in the case of this, commands would use the write DB, queries would use the read DB. What it does do is possibly introduce eventual consistency into your application, because our write database may not be 100% in sync all the time with our read database. And performance reasons, it may be optimal to go for an eventual consistency model where our read database will eventually be consistent with our write database. But this does introduce the possibility that our queries might not be as up to date as our write database. But this can be orders of magnitude faster than using a single database, depending on how the architecture is set up and configured. Now, I just want to draw attention to one other type of usage with CQRS, and this is CQRS with an event store. And often you'll hear CQRS talked about in the same sentence as the event store architecture. In this case, we have, or the big difference here is instead of using a relational database, we use an event store. And an event store, as the name implies, stores events. And this keeps track of the historical events that make up the current state of the application. And it uses a different persistence medium called an event store. And as a command comes in and updates the domain and a persistence, then these are stored as events that can then be replayed in order to get the latest query from our read database. So our event store is going to play these events into our read database, so this is up to date. And this also introduces some complexity into the application. And one example that's sometimes used to describe an event store is, imagine your bank provided you with this balance. And you were like, okay, that's fine. But then the next day, your balance updates to $100. Now, this is typically how we treat a relational database. We have an object and it has a value. And we'll update that value, but we don't keep track of what happened or what event happened in order to update that value. And if this was all your bank stored, and you phoned them up and said, hey, I don't think my balance should be $100, it should be $200, your bank will shrug their shoulders and say, well, we don't really know what happened here. But the idea of event sourcing is that every event is tracked and recorded. So if your opening balance was $200, and then you had an event to buy a widget, and then there was an event to buy some food, then your balance would be the result of these events. And if you phoned up your bank and said, hey, why is my balance $100? They would say, well, you did buy this widget and you did buy some food. And that's the reason your balance is $100. And this is the idea behind the event store architecture. Now, it does have some pros and cons. It's very scalable because the number of reads in any application is always going to be far higher than the number of modifications inside an application. And applying this type of CQRS pattern allows us to focus independently on both of these concerns. And one major advantage of that is we can scale our reads very differently from our writes. And we can allocate more resources to our read, make it a different type of database, and so on. And it's also very flexible as well because it's very easy to update or add on the read side without changing anything on the writing side. And our events are always immutable in the case of an event store. There are some cons, and the fact is it's significantly more complex than the other patterns. Also, it doesn't modify state, so a relational database is not going to cut it for an event source. And there's additional costs that comes along with this complexity. Now, I didn't want to go into any great detail of event store because we're not using that in our application. And I will put up a link. There is a great talk by Greg Young who goes into event store in significantly more detail if you do want to know more about it. But it's not something we're going to cover in this course. But what we are going to take a look at next is communication between our API and our application. And for that, we're going to use Mediator, and we'll talk about that next.